Hi, this is Mervin from 4th year CSE. So we're here for the third exercise of the data mining lab, which is K nearest neighbor based classification. So now I'll show you how to do it. So this is our screen and this is my recording software. Let us move to the corner. Yes, and that should be about it. So now we have the iris dataset which we're going to be using. So I just drag and drop it here. So this takes up the retrieve iris. So now this is the input and the output which will contain the iris dataset. Now what operator I'm going to be using is an operator called as cross validation. So this I drag and drop it here, and then we connect the required results to, that should be about it. So this is the validation which we use to validate the dataset, and now we double click on the validation. So basically it takes us to two things. So this is the training space and this is the testing space. So in the training space we do train the data set, or train the machine rather, to make decisions based on the analysis, and in the testing phase we actually test the performance of the analysis. So in the training phase, the operator which I'm using is called the KNN, which comes under the lazy learner. So I put it here. So the input is our data set and the output is actually a model uh, which is gotten from the data set. So we connect it here. So the parameters to the KNN are K, which you can give any custom value to. So let me give 3 over here. So now let us move to the testing space. So moving to the testing space, the operator which I'm going to be using is called as the apply model, which takes in a model and gives the output as a labeled model. So we take the applied model and drag and drop it here, and then we connect this. Yeah. Uh, 1 second. And then we connect the output, which is this. So now we've successfully finished connecting it. So now we go to the process, and now when you click on go, we get the results. Sorry, there seems to be an error here. 1 second, let me rectify it. Sorry, I forgot to do an important thing in between, which is the performance based on the classification based on the performance. So sorry. So when you say performance, there are a lot of options given here, which are basically performance based on classification, and likewise. So I choose performance based on classification, which actually checks the performance depending on the testing which we've done until now. So we connect the required things, and now I think this is done successfully. So now when you go back to the process, it's saved. All the components that we did inside validation was saved successfully. Now when you click on go, you actually get the results of what we've been trying to do. So these are the results. So this is the performance vector. Let us wait for this to finalize. So our accuracy is 96% plus or minus 3.27. So here we have the precision of our classes. Basically we have three classes, which are setosa, versicolor and virginica. So the class recall percentage are 100% for setosa, 94% for versicolor, and 94% for virginica. So this is something in the range of 90 to 100, which is pretty high, and we don't have a problem with this. So this is the iris data set which we had in the beginning, and in the KNN classification, it gives you a summary of what has been done. So because we put K as 3, we have 3 nearest neighbor model and the 4 dimensions of the following class. It says 150 examples were taken into account. So now we also have a plot view, which is a graph. So the x-axis shows you the true class, the y-axis the predicted class, and the z-axis shows you the counters. So that is about it. This is how we found the k nearest neighbor. Thank you for watching.